All right, so this is your assignment on simple harmonic motion. Okay, it's fairly straightforward. There's only one question on here that's a little different than stuff that we've done in class multiple times. Okay, so I'll give you a couple of tips on that one. But the biggest tip here is don't overthink it. Okay, if like look at what the points are worth and kind of go appropriately from there. So question number one, you're just looking for the period of a pendulum. Or sorry, if you're given the period of a pendulum, you're just asked to find its length. So show your givens, show your formula, manipulation, and answer. You got your 4 marks. Okay. For number two, you got another pendulum question, and it's just asking you about basically the effect of gravity there. So you're just calculating a different length. Number three, again, another pendulum question. Okay, fairly straightforward. Just be mindful of the number of cycles. Okay, it makes 100 cycles in 280 seconds. Okay, so just make sure you keep those in mind when you're doing that. Okay, number four, wrecking ball, also a pendulum. Okay, the thing here is you've got a ratio of one pendulum to another pendulum. So you got a wrecking ball that's really long and it's making swings like this, and then you've got a little pendulum that's doing this. Okay, the little pendulum makes 5 cycles. So that's out and back 5 times, and the time it takes the wrecking ball to go out and back once. Okay, so keep that in mind on that question. And then number 5, a pendulum. There's a lot of pendulums on this one. Okay, so they're giving you the length, they want to know the period, and then they want to find out how long the pendulum would have to be to double its period, and then why is that number not just double the length. Okay, just talk about the period formula, okay, for a pendulum. We did lab on that. Okay, so you guys should be able to handle that one. Number 6, okay, pendulum oscillating on the moon. Knowing that the moon's gravity is 1/6 that of Earth. Number 7 is the oddball. Okay, so it's a mass on a spring question. Okay. So when an object of mass 1 is hung on a vertical spring and set into vertical simple harmonic motion, the vertical part makes no difference for this question. Okay, the frequency is 10 hertz. When another object of mass 2 is hung on the spring along with the first mass, that is the key part of this question. Okay, in the second situation, both masses are on the spring. Okay, both of them are there. Okay, the frequency of motion is 5 hertz. Find the ratio between mass 1 and mass 2. You're not actually being asked to find mass 1 or mass 2 because, spoiler alert, you can't. Okay, but you can find the ratio between them. Okay, you may need to find numbers that represent mass 1 and mass 2. Okay, the ratio is what you're looking for. You're not actually going to get the real masses. Okay. Right, that's the trick. And then number 8, you got a spring with a constant there. You got the spring constant. You've got the frequency. Okay, you're looking for the mass that's suspended from it. Number 9, mass on the spring question. Okay, and you're looking for the frequency of the motion, knowing the spring constant and the mass. Okay, number 10, a bungee jumper is a mass on the spring. Okay, and after taking a leap, they give you that they oscillate with simple harmonic motion over 30 seconds. They oscillate 5 times. It's little things like this you have to watch. Now, is that a measured number or a counted number? If I watch somebody and they go 1, 2, 3, 4, 5. Did I measure it or I count it? Counted it. Counted numbers don't count for significant digits. Okay, because they're not measured, they're counted. You have absolute certainty in your counting. Right? For number 11, okay, you've got another spring question, and you're given the maximum speed of the object this time, and the maximum displacement. You're looking for the mass. Okay, so we're changing now from questions about like period and stuff like that, okay, to like Hooke's law and conservation of energy going forward. Okay, Number 12, okay, object vibrates at the end of this spring on a frictionless surface. Okay, potential energy is 4.9 joules. Okay, I think I updated. This isn't 6 on your sheet, is it? This is like 3 on your sheet, right? Yeah, because those point values were ridiculous. Okay, so my point values on here may not match what's on your sheet because I forgot to change this back over. Okay, look at the point values for 12 and for 13 and do the appropriate amount of work. They are quite simple. Okay, so don't overthink. All right, questions from you guys? All right, then I'll shut up and you can get to work and have the whole class to work on. Okay? Good.